All right, skills practice with ratios. First, we're going to write each ratio in lowest terms in the 3 different ways. So 8 dogs to 40 dogs. Well, if we're going to think about 8 and 20, those are each divisible by 4. So I really have 2 to 5. So with the colon, 2 to 5 as a fraction, 2/5 as a decimal, we divide 0.4. 14 feet to 13 hands. Well, we can't do any reducing there. So colon, fraction, I use that fraction bar as a divider button, and I get 1.077, and I rounded there. 6 hours to 6 minutes. Well, let's think about it. There are 60 minutes in an hour, so this is really 360 minutes to 6 minutes. So these are both reducible by 6, and I end up with 60 to 1. So 60 to 1, 60 to 1, and the last one is a decimal, so just 60. 15 cents to $2. Well, $2 is the same as 200 cents. So 15 to 200, those are both reducible by 5. So I end up with 3 to 40. I don't know why I put it 2. 3 to 40. So, colon, fraction, decimal. And there's your 3 different ways. Now we're going to write the fraction in lowest terms. We're going to talk about a sentence, and I'm not going to write the sentence, I'll just talk about the sentence, and then we're going to write it as a decimal and again with the sentence. So first, fraction in lowest terms. I've got 24 and 10. They're both even, so I'm going to divide each by 2, and I get 12 people to 5 homes. So my fraction will be 12 over 5. Now, people are on top, homes are on the bottom. So your sentence, there are 12 people for every 5 homes. You're just putting the words in a sentence. Now, as a decimal, we take 12 divided by 5 and we get 2.4. When you change it to a decimal, that's like putting it over 1. So that means there are 2.4 people per house or per home because there's a 1 on the bottom. So 2.4 people per 1 house. All right, let's do that again. Now we've got 1,020 seats to 8 movie auditoriums. Well, these are both reducible by 4. So I have 255 seats to 2 auditoriums. So as a fraction, I get 255 over 2. Think about what those stand for. There are 255 seats in every 2 movie auditoriums. There's your sentence. Then we go to a decimal, and so I divide those and I get 127.5. Remember, that's like per 1. So that means there are 127.5 seats per auditorium. And they're, write it out with a, complete sentence, complete with a period. And there's your sentence. 30 hot dogs to 40 hamburgers. Well, these are each reducible by 10. So I really have 3 to 4. Now, as a fraction, 3 to 4. So there are 3, remember the top is hot dogs, the bottom is hamburgers. So there are 3 hot dogs to every 4 hamburgers. When you go to a decimal, you're at 0.75. So there are whatever comes first, there are 0.75 hot dogs for each hamburger. You always want the 1 on the bottom. 254 pieces of luggage to 6 planes. That should say planes, not plans. So when I go to reduce these are both even, so they're reducible by 2. And I have 127 pieces of luggage to 3 planes. So as a fraction, I have 127 over 3. Again, on the top we have luggage, on the bottom we have planes. So there are 127 pieces of luggage for every 3 planes. And there's your sentence. When you go to your decimal, you divide, and you get 42.33. So there are 42.33 pieces of luggage per plane. That's what that last piece means. All right. All right, so we're making punch for a party. The punch has 3 ingredients: soda, pineapple juice, and OJ. And the recipe you're going to use is 4 cups of OJ, 2 cups of soda, 4 cups of pineapple juice. Total 10 cups, right? 4 plus 2 plus 4. So the first one, ratio, cups of soda to pineapple juice. So we want soda over pineapple juice. Well, soda, it says 2, pineapple juice is 4, so that reduces to 1/2. Now, part to part or part to whole. We didn't use a total of 10 cups, so we are just part to part. Write a meaningful sentence. Well, for every 1 cup of soda, you would have 2 cups of pineapple juice. There's your sentence. Same problem. Now we're going to talk about ratio of pineapple juice to soda. You might think we just did that. Well, we did it the other way. There are 4 cups of pineapple juice to 2 cups of soda, which is 2 to 1. It's still part to part because we're not using the total, but you only are talking about, now we're talking about pineapple juice first, so it does change the ratio. So you would say for every 2 cups of pineapple juice, you would use 1 cup of soda. All right, another one. Now it says the ratio of cups of OJ to cups of punch. So we're talking about OJ to the total. Well, if you think back, we needed 4 cups of OJ. So we had 4 on top out of the 10 total. Now as a ratio, we're talking 2 to 5. Part to part or part to whole? Well, because we're comparing to the total, this is part to whole. All right, let's express this in a meaningful sentence. Well, out of 5 total cups of juice, 2 of them would be OJ. But it would be easier to go to a percentage because remember, part to whole can be written as a percent. So 2 out of 5 is the same as 0.4, which is 40%. So 40% of the punch is OJ, right? Part to whole, totally easier to talk about because you can deal with percents. All right, let's change gears away from the punch and to some laps. So every 3 laps that Kathy ran, Susan ran 9 laps. Okay, so we have kind of a ratio of 3 to 9, Kathy to Susan. When Kathy finished 1 lap, how many laps had Susan run? So we want Kathy to have run 1. Well, think about it. How do you go from 3 to 1? Well, you divide by 3. So on this side, if I divide by 3, 9 divided by 3 is 3. So that means Susan had run 3 laps in the time that Kathy finished 1 lap. Okay, so we still have the 3 to 9 is the initial ratio here. Now it says when Kathy, remember Kathy is first, when Kathy finished 3 laps, how many had Susan run? Or when she finished 9, excuse me. So we're now saying that Kathy ran 9. Well, how do you go from 3 to 9? Well, you multiply by 3. So on this side, we're also going to multiply by 3. 9 times 3 is 27. So that means Susan ran 27 laps in the time that Kathy finished 9. It's like me compared to a marathoner, right? They can run, dang near 7 miles in the time it takes me to run 2. They might be able to run faster than that compared to me. Anyway, number 14. When Kathy and Susan have completed a total of 16 laps, how many of those laps were Kathy's and how many were Susan's? Well, okay, we know we had a 3 to 9 ratio, and that made us, we reduced that to 1 to 3. So this was Kathy, this was Susan, and that means they ran a total of 4 laps because Kathy did 1 and Susan did 3. Well, if we double that, 2 to 6, that gives me a total of 8. 3 to 9 gives me a total of 12. 4 to 12, right, every time we're increasing with the same 1 to 3 ratio, that gives me a total of 16. So that means Kathy did 4 and Susan did 12, if you can kind of think through that process there. All right, now we're going to kind of think about the different groups of populations and dealing with dependency ratios for a little bit. So this first problem starts with find the ratio of the population 29 years and younger to the total. Well, they give us the total, but under 29. So take a minute and add up all of these numbers because that's the 29 years old or younger. So add those up and you should get 125,955,404. And when you divide that by the total, 308,745,538, you should get 0.408. Now, when you think about this, this is a part to whole ratio because we're comparing it to the total, which means I can write this as a percent. So it means that 40.8% of the population is 29 years old or younger. That's what that means. Now we're going to find the ratio of the population 80 or older to the total. So 80 and older is down here. So we add these two together, and we just get 11,236,760. Quite different than the 125 million of our 29 and younger. But again, we're comparing to the total. Now, when you do that, you get 0.036. Again, this is part to whole because we're comparing to the total population, and therefore we can say 3.6% of the population is 80 years old or older. So again, part to whole, you can write them as percents, and that makes them just a little bit easier to talk about. Okay, now let's go dependency ratios. So child dependency, remember, is 0 to 14 years old divided by 15 to 64. So you're going to say 0 to 15. Here's my children in yellow. And then the working population is in teal. So go ahead, hit pause, add those up, give me a fraction, and go ahead and finish out this page, and then come back and watch what the answers are. All right, so hopefully we get the same numbers when we add, but we get a child dependency ratio of 0.295. Now, because we are comparing part of the population to a different part of the population, this is part to part, and the interpretation of this, we have 295 dependent children on 1,000 workers. Now, you could say 0.295 dependent children on each worker, but that doesn't make any sense. I like to actually use concrete numbers that actually make a little bit more sense. So hopefully that works in your head. All right, let's do old age dependency ratio. So now the old age, remember, is 65 and up here in yellow, and your working class is going to be the same number as you just used. So go ahead and find that one, finish out this page, and then, so hit pause, finish it, come back and watch. All right, so there are 40,267,984 oldies compared to our working class, which gives us an old age dependency ratio of 0.194. Again, this is part to part, and the meaning there are 194 oldies dependent on 1,000 workers. And there is the meaning of that age dependency ratio. Now we're going to do straight up age dependency. And remember, now we have to add the children plus the oldies compared to the workers. So you've got the children plus the oldies compared to the workers in the middle. So go ahead and hit pause, complete this page, and then come back and check out the answer. So we have 101,495,197 dependents compared to the working class. Now these are still two parts of the population, so it's part to part. In this, the ratio is 0.490. So there are 490 dependents on every 1,000 workers. So each worker is almost supporting an additional half of a person on top of themselves, is basically what that means. And that is the end of the ratios skills practice.